Welcome to the third module of cloud computing. In this module, we will take a look at the characteristics of cloud computing. So, as we already have seen an overview of cloud computing and we have already discussed the resources of cloud. We have seen that data centers is the place where the servers and the storage should be included or kept, housed with appropriate technologies or mechanisms for networking, for connecting them, for providing the service, and of course, whatever security from natural and man-made disasters that can be done. Next, we will take a look at the infrastructure. The infrastructure are the essential requirements of infrastructure is that it should be distributed, it should be virtualized, and the system should be an autonomous system. So, when we say it is a distributed infrastructure, what we basically mean is that the requirement of the system is that the servers or wherever from the service is being provided is not located in the same place as the users. The users should be able to acquire the services or provision the services from a remote location from wherever they are. And this perhaps is the most important characteristic of cloud computing. The next infrastructural requirement of cloud computing is resource virtualization. As we have said that virtualized environment is a requirement for cloud computing as given by many organizations and individuals who have tried defining cloud computing. Essentially, the meaning of virtualization is that we do not expose the actual location or the mechanisms of the underlying hardware. We can put one indirect layer of indirection on top of the hardware and allow users to flexibly use the underlying resources. We will talk about virtualization in detail in later modules, since virtualization is a very important part of cloud computing. The third point of infrastructural requirement is autonomous systems. The systems in a cloud computing should be autonomous in the sense that without intervention, without human intervention, the system should be able to continue on their own, and the mechanisms of the systems are such that each one can independently work. They really do not need the dependence of having another computer or another system. So, essentially what is the requirement is that each one of the resources in a cloud computing should be an autonomous system. It should be able to hold on its own and continue working on its own, and it can also work along with other systems that are connected in the environment. This basically is a requirement of distributed computing or distributed systems, where we say that each computer should be a part that is a part of a distributed environment should also be an autonomous computer having their own memory, having their own processor, having their own mechanisms, and being able to continue on its own. The distributed environment helps such many autonomous systems to work together to achieve a better goal than a single autonomous system can do. Since we have seen from the history that cloud computing is nothing but a distributed system, so of course the infrastructural requirement of cloud computing is that each system should be an autonomous system. So, we have seen the resources and we have seen the infrastructural requirements of cloud computing. Next, we will look at the defining attributes of cloud computing. These are also called the essential characteristics. These essential characteristics are defined by NIST. They are on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. So, what does on-demand self-service mean? It means that a consumer can on its own acquire and consume a service provided by the service provider. Why it is called on-demand? It is on-demand because the user does not require to inform in advance or follow the program of the service provider. If we take the example of television, a television is not an on-demand environment, because whether we can switch on or switch off the television at any point in time, we cannot dictate or we cannot decide what program we are going to watch. In recent years or recent time, we have seen that on-demand television has arrived, which means that I not only can switch on the television, we can also tell or decide which program we want to watch, and that program will be given to us, telecast to us. Now, why we call cloud an on-demand self-service? Because whatever service among so many services that are being offered by a cloud service provider, whatever service is required by the user can demand or use that specific service without any prior intimation to the service provider. So, therefore, it is on demand and therefore, it is self-service. It also has a requirement that automatically it should be done without any human interaction. The next essential characteristics says that it should be broad network access. What does broad network access mean? It means that the capabilities should be available over the network, and the mechanisms of that should be a standard mechanism. That means that the networking mechanisms should not require a special setup by the cloud provider or the cloud consumer. And the other requirement says that for the devices which will be used by the clients can be heterogeneous. It can be the mobile phones, it can be a tablet, it can be a laptop, it can be a workstation, it can be any new device that is coming to the market. So, a broad network access has two fundamental importance. One is a network access and the other is that the network access should be a broad network access. Since cloud deals with a huge amount of data and large computations are expected to be done in cloud, so broad network access is a very important requirement, wherein it shows that the need for the communication bandwidth is a very large requirement which should be fulfilled by the both consumer side and the provider side networking. The next essential characteristic is resource pooling. What it means is that the resources offered by the provider, service provider, should be pooled together. What are these resources? These resources are storage, the processing capability, memory, and the network bandwidth. All these are resources given by the service provider and they should be pooled together, maybe stored in a data center or a number of data centers, so that user can easily access it. And the other concept of resource pooling is that the consumers can get these services any number of time and any number of consumers, which is the multiple consumers. From this concept came the concept of multi-tenancy, which we will discuss in a later slide. And also the service should be dynamically assigned and reassigned according to the consumer demand. As we have already seen that on-demand service is a requirement, if we combine the requirement of on-demand with resource pooling, we can easily understand this, that I may need one service and then immediately after that I may need another service, or I may need a combination of certain services, and whatever is my requirement, since it is an on-demand, the resources should be put together by the service provider so that the services can be deployed very easily and quickly. And the third requirement of resource pooling is that the services should be location independent. From whichever part of the world the user is contacting a cloud service provider, the user should be given the service without bothering about where the service is located. So, therefore, it should be location independent. And these of course are true for both physical and virtual resources. The next characteristic is rapid elasticity. The capabilities of elasticity, elastically provisioned and released, in some cases automatically and definitely rapidly. So, what is the concept of elasticity is what we see from a normal elastic material, that if we pull an elastic material, it grows. When we release them, it shrinks back to its size, or even it shrinks smaller than that. So, how elasticity is related to computing? Elasticity is related to cloud computing from the perspective that the amount of resource that is available or is made available to the user should look unlimited to the user, which means if the user requires a specific resource, at whatever amount the user is requiring that resource, it should be made available to the user without any concern as to whether the provider has that much amount of resource or not. A simple example of elasticity is perhaps if we need during a specific peak requirement, when we need more computing power than what we need in a normal requirement. In an academic institution, we can think of an examination time where the laboratory examinations will demand a lot more computing power and storage resources than during the normal semester hours. So, therefore, during examination, the resources should be elastic enough to grow perhaps on its own, or it looks like it is growing on its own, and be able to fulfill all the demand of the users. On the other hand, when during the normal semester time, when the demand is much less, the resources should be able to provide less, the providers should be able to provide less resources during such times. So, this is the concept of elasticity, and because of the concept of elasticity in cloud, the resources always look unlimited, although at later part of our course we will see that this is a myth and we have to work very cleverly behind the scene to ensure that elasticity is provided to the cloud users. The next essential characteristics of cloud is that it is a measured service. Now, what is the concept of a measured service? The concept of a measured service is that the resource used by the user should be measured using a metering capability, and the resource usage should be monitored controlled and reported, providing transparency for both the provider and the consumer. So, the concept of measured service comes from the concept of utility computing, or to be more precise, utility service, where we say that the amount of consumption should be metered and should be measured, and the amount of payment from the user should be based on the amount of consumption. So, unless we keep a track of how many newspapers we have consumed, or how much of electricity we have consumed, we cannot pay for that exact amount. So, therefore, what we have is an electric meter which records the amount of consumption, and end of a month or end of a cycle we regularly pay for exactly the amount of electricity that we have consumed. In a similar vein, since cloud computing is a utility service, it is a kind of utility computing, so there should be a meter of usage for both computing as well as storage resource that is going to be used or consumed by the user, and the user will be paying the service provider according to the usage of that particular user. So, this metering should be very transparent, which means that there should not be a question of whether actually this much of service has been consumed by the user or not, and it should be a monitorable mechanism, which means that at any point in time, if there is a debate or a doubt on the part of the user, they can always go back, check and verify that the amount used by the user is the amount being charged by the service provider. This is a very important aspect of cloud computing. Unless a proper appropriate measured service is implemented, it is very difficult to make this work possible. Now, the essential characteristics are also looked by different organizations differently. For example, the Gartner says that there are 6 essential attributes of cloud services. These are service orientation, scalable and elastic, shared, metered by use, outcome focused, and use of internet technology. Let us look at these in a little detail. Service oriented, as we have been saying, that the essential characteristic of a cloud is that it should be providing or offering all its mechanisms in the form of a service. So, therefore, of course, Gartner says the essential characteristic is service orientation. The next one is scalability and elasticity. NIST agrees with this point, saying that the service provisioning should be elastic in nature, by which the user should feel that the provisions are unlimited, the resource provisioning is unlimited, and any amount can be used. Scalability is what Gartner has added to this point, saying that elasticity is very closely related to scalability. The third point is that it is a shared set of resources. Indirectly, this is also mentioned by NIST in the sense that it is a shared pool of resources, which means that the same server will be used by multiple customers or clients at the same time. This is the concept of sharing. So, how this is managed by the cloud is the technology that works behind the cloud. The next point of Gartner is that it should be outcome focused, which means that this is true for any service based organization or any utility service for that matter, that however hard behind the scene the providers are working, unless the services are provided appropriately, properly at the time of service provisioning, it is not possible for the users to really appreciate the hard work. So, therefore, Gartner mentions that an essential characteristic, since cloud is a utility computing, which is a kind of utility service, it should be totally focused on outcome. The user satisfaction, the ability to deliver service on demand, appropriately doing rapid provisioning should be one of the major essential characteristics that a cloud provider should look at. The last and not the least, of course, is the use of internet technologies, as also in NIST definition and all the definitions mention that cloud resources should be connected to the outside world. And this connection, Gartner says it should be internet based. Typically a cloud is internet based, but later on we will see that there is a kind of cloud which may not require internet, but we will come to that later. So, with these we have seen almost all the essential characteristics, but one characteristic which is called the multi-tenancy is a very important part of cloud computing, which should be understood at this stage for a better understanding of cloud. What multi-tenancy says is that it is a sharing of infrastructure resources across multiple clients, which means that all the resources, hardware, software, any utilization should be shared on a multi-tenant basis. A typical example of multi-tenancy is an apartment house. If we compare it with an individual house, we can easily understand the concept of multi-tenancy. In an apartment house, there will be a lot of common spaces which will be used by all the occupants of that apartment house. No one single entity really can occupy one of these spaces and others cannot be banned from using it. This same concept is used in multi-tenancy. Let us look at this example where an application 1 is being implemented. It requires the operating system, it requires its database and application server, it requires an underlying server perhaps, it requires its necessary storage and the network to be able to implement this particular application. If we want to implement another application, I can perhaps again acquire a similar set of resources and implement application 2. Similarly, a third application can be implemented using a set of similar resources. This is an example of a single tenancy where each of these applications have devoted or dedicated software stack which they are using, application 1, application 2 and application 3. So, all the configuring, monitoring, upgrading, security, all the requirements including disaster recovery is the headache of center, connects them using networking and then makes these resources available to the general public at a certain cost. This cost should be small enough for the users to benefit and this cost should be sufficient for the service provider to ensure that their required cost is covered when there are many such users using the service. On the other hand, a private cloud is an infrastructure provisioned for exclusive use by a single organization which has different consumers. It will be owned, managed and operated typically by the organizations, or otherwise it can be a third party or some combination of this. It can exist on premise or off premise. Now, a private cloud is a cloud which is created for the benefit or the requirement of a specific organization. The organization creates it and then allows its own users to consume the services. Why is it that it is possible to house these private cloud on or off premise? Is because many times it is not possible for an organization to provide what is known as a data center or the requirements of a data center, in which case one can hire a data center space and house its own servers and the storages in that particular data center. So, therefore, it can be on premise or off premise. Now, the concept of private and public cloud is very different from each other, in the sense that although both are cloud, they are meant for a specific set of users in private, whereas they are meant for general public, for general crowd for the public cloud. So, the growth prediction, as we see, is that in 2013, 78% was given for the private cloud and 22% was meant for public cloud, whereas when the prediction comes to 2018, we see that 69% has been provided for private cloud and 31% for public cloud. A community cloud is a cloud which is meant for a group of organizations which may have a specific interest together to create a cloud, and these users will be the consumers which are there. A hybrid cloud is a combination of a public and a private cloud. To summarize this module, we have seen the characteristics of a cloud. We have seen how NIST defines these characteristics. We have also seen how Gartner defines these characteristics, and we concluded that essentially they are quite similar to each other. And next we saw the deployment models. We saw how a public cloud, what a public cloud is, what a private cloud is, what a community cloud is, and what a hybrid cloud is. In the next module, we will look at the services, the types of services, and how these services are provisioned in a cloud environment.